Alright, here we go now. I took out this complete front regulator right here, and I brought the unregulated DC supply over to the feedback circuit so it could be one unit. And let me show what I did here. Right there is a completed circuit now for this. I'm coming right off the supply here with an unregulated voltage input. It's a filtered bridge circuit here so that I can get the pulsating and get it to, with a filter here, get to a nice, pretty close to steady DC voltage is all I need. But now the voltage coming off of the power supply here is going right down through here into the motor. Everything through here now is nothing more than the torque control circuit, and that's all it is. And so now it's the same thing as we had before. I just changed this transistor to a 2N3055 to get to a power transistor. I have a power transistor here. The rest of these are small signal transistors, and it's working really good. And let's do a demonstration now and see how it works. Okay, first I'm going to hook up my benchtop supply to the motor directly. And I'm going to put 8 volts across that, about 8.5 volts. Now this motor is directly across the commercial power supply that is fully regulated. And I'm going to now put a stall on it. Okay, and let's check the voltage drop. Okay, I'm going to put a stall on the motor now. Okay, it's fully off and it drops to about 8 volts, so we dropped about a half a volt. Now I'm going to hook the motor up to the regulator circuit, or the torque circuit here, and then I'm going to also use the commercial supply to run this, and we're going to see how this enhances and gives a torque control now. Okay, so now I have the commercial power supply hooked up to the torque circuit, and I'm now hooking up the motor, and I now have to adjust the power supply, the regular supply now, until I get the motor voltage up to 8 volts. 8.5 volts. Now we're at 8.5 volts on the on this here supply here. But I have to get this up to 16 volts because that's what this here circuit is designed for. At this point right here, I'm at 8 volts, but since my supply voltage is only at 10 volts, I'm not going to get the regulation. I'm going to stop the motor. I don't have the regulation yet because this is designed for an input of 18 volts. I'm sorry, not 16, 18 volts. So now I'm going to raise my power supply until the left voltage reads 18 volts. Now we're at 18 volts. 18 volts there now, and we're at around 8.7 volts across the motor now. So now the circuit is working at 18 volts input with a regulated supply, and now we're going to put a stall across the motor. There's the voltage. Now I put a stall across the motor, and the voltage goes up. If I drop that down to about 8.5 volts, as long as the power supply remains around 17-18 volts there, I have torque. If the power supply goes down below that voltage, then I get all kinds of erratic here because it's jumping back and forth. So I have to get it right to the regulated, I have to get it to the supply voltage that I designed it for here, which is 18 volts. And now I have the proper voltage across the motor for torque. I'm holding the washer on the outside here that's got a, and it's still moving, it's still trying to move my fingers like that. And that's keeping me at 9 volts. I let go of the motor and it drops back down to 8.5. So we have the torque that we're looking for. But another thing to look at too is, since the circuit was designed for an input of 18 volts, as long as that's 18 volts, this works. If this drops down, even if this remains at 8 volts across the motor, right now the motor is at 8 volts again, but this has dropped down past the design value. And so if I go to stall the motor, it stalls just like it would normally. I have to get the power supply back up to 18, and then now it'll work the way it's supposed to. Now I put a stall across the motor, and it increases like it's supposed to. So that shows again how it has to work according to the design parameters too, which is really very interesting how this works like this. Okay, so now we see how we can make the torque converter work with a regulated supply, and now it's time to make it work with a unregulated supply, and that's coming up next. Okay, I'm still on the benchtop regulated power supply, but I want to explain here now why this works the way it does now. Right now we are running the whole circuit at 10 volts. We still have 8 volts dropped across the motor, but because the circuit requires 18 volts input, this will not torque right. All right. Now, as I increase the input voltage here, listen to the motor, how it revs up. Now, when I get to about 16 volts, we're going to start getting some feedback. Is what we want looking for. Now we're getting a little bit of feedback. See how the voltage across the motor is raising as this is raising? Oh, watch this now. So I continue. Now we got feedback. Now we're getting the feedback we designed this for. Now the voltage across the motor is going to start dropping back to 8. Now we got full feedback. The voltage across the motor is around 8 volts, and the input is around 18 volts, and you can hear the motor. You can hear the motor pulsing now because it's got the feedback. Every time that pulses, that's the feedback being introduced. If I lower the input voltage again, we lose the feedback. Now we lost the feedback. And so now the motor voltage again is about 8 volts, and we can stall it and drop the voltage because there's no feedback. Increase the input voltage again. Right there, feedback. There's the feedback that we designed it for. Get up to 18 volts, and now we got full torque. There it is. That explains it now, why it has to work at that specific voltage. It was designed for that, and that's what's working at. So I'm very pleased with the results of that, how that's working. And I'm learning a lot now how this works also by experimenting here. Okay, now we'll put it on the unregulated supply and we'll see how it works again. Okay, we're on the unregulated supply now. And so again, you can hear the motor pulsing. And I put a stall across the motor. And there the voltage increases. Okay, so that proves it real good right there. So, okay, I would say now that this circuit is working properly as far as the design of it for torque conversion. And now the next thing would be to just, the prototype is done, and now the next thing to do would be to scale this up now to work with my lathe motor. And that'll probably be the next video now, will be once I get everything put together and built and upscaled now to run my lathe motor, and then I'll give a demonstration how that works. All these videos was the experimental stages, the research and development of getting this thing to work properly, and getting a knowledge of how to make this work, and very successful. So I'm very pleased with this project of this prototyping this now. So now comes the actual build now coming up next. Thanks for watching. Bye.